Greetings to Doctor and everyone. Today we are from Group 3 going to present our project. There are 7 members in our group including myself, Pavitra, Nurul Shafina, Nur Zulaika, Wichia Lee, Nurul Ain, Nur Aina Nasuha and Muhammad Danish.
Assalamualaikum and good day everyone. Today I will present part 1 of our project which is data generate. Step 1. Construction a C from student ID. First, we collect the last 4 digits from each group member student ID. The last 4 digits are student 1 is 0411, student 2 0636, student 3 0768, student 4 0747, student 5 0760, student 6 0661, student 7 0708. Each for this 4-digit number is treated as an integer and will be used as the C for data generate in the next step of our project. Step 2. Compute the C value. Next, we add all the 4-digit number together to form a C value S. So, S equal to 0411 plus 0636 plus 0747 plus 0760 plus 0661 plus 0708. After calculate, S equal to 406.691. The value will be used as the C for the next step. Step 3. Generate matrix A and vector B. Use the C value for 406.691. We generate a matrix A and vector B. The generate matrix A is A equal row 407, negative 6, negative 97, negative 61 row. And the vector B is B equal to row negative 4, 8, 21. We calculate the determinant of matrix A. Determinant of A is 97.000, which means matrix A is invariable. The process is implemented using Google Colab Python. In conclusion, we successfully construction a C from student ID. Calculate the C value as equal to 4691. Generation matrix A and vector B using Python. Verify that matrix A is invariable.
Hi, my name is Wichia Lee. Here I will present the Part 2A manual analytical solution. First, write the system in 3 simultaneous linear equations in the unknown S1, S2, and S3. The left side matrix A and vector B is the answer from the Part 1, and the right side is how to write in 3 linear equations. After write the 3 linear equation, next I will use the Gaussian elimination method to find the unknown S1, S2, S3 in vector form. So the first step is write the augmented matrix. So use the 3 linear equation, write in augmented matrix. After change in augmented matrix, next use elementary row operation to reduce the augmented matrix to row echelon form. So the step 1 is to create the leading one, need to change row 1 by 1 over 4 times row 1. So the left side is augmented matrix before change the row 1, and the right side is the answer after change the row 1. After the After create the leading one, next we need to create the 0. So we need to change the row 3 by row 3 minus 7 times row 1. So the left side is the answer before change the row 3, and the right side is the answer after change the row 3. And the below one is the step how to change the row 3 element. After create the 0 in the first column, next we need to create a leading negative 1 in the second column. So we need to change the row 2 by 1 over 9 times row 2. So the left side is the before change the row 2, and the right side is the answer after change the row 2. And the below one is the step to change the row 2 elements. After create the leading negative 1 in the second column, next we need to create 0 in the second column. So we need to change the row 3 by row 3 minus 73 over 4 times row 2. So the left side is before change the row 3, and the right side is the answer after change the row 3. And the below one is the step to change the row 3 elements. The right side is the answer row echelon form.
Hi, my name is Nozulaika binti Mama Hafiz. I will continue with part 2a. Now, we use batch substitution together with the Gaussian elimination method to find the values of x3, x2, and x1 step by step. First, we write the corresponding system of equations for each row. On this page, we find that x3 is 260 over 97. On this page, we find that S2 is 116 over 97. Lastly, we find that S1 is 90 over 97. By substituting the obtained values into the previous equations, we obtain the solution vector X in column vector form. This represents the final analytical solution to the system AX equal B.
What is being verified? In part 2b, we are verifying the equation Ax equal to b. This means we are checking whether the solution vector x when multiplied by matrix A gives the vector b. If this condition is satisfied, then x is indeed the correct solution. Step 1. Inputting the data into Python. First, we enter matrix A which contains the coefficients of the system. Vector B, which contains the constant values, the analytical solution vector X obtained manually in part 2a. These values are entered exactly as calculated without modification. Step 2. Matrix multiplication AX. Python then performs matrix multiplication between A and X. Mathematically, this operation computes the dot product of each row of A with the vector X. This produces a new vector that represents the left-hand side of the system. Step 3. Comparing AX with B. After calculating AX, Python compares the result with B. If each corresponding component of AX is equal to B, then the equation AX equal to B is satisfied. In the output shown, the compute values of AX match B, where either exactly or within a very small numerical tolerance. Interpretation of the output. These results confirm that the analytical solution from part 2a satisfies all three original equations. The Gaussian elimination steps were performed correctly. The computational or algebraic errors occurred. Thus, the manual analytical solution is verified and correct.
For part 3a, we apply the Jacobi interaction method to solve a system of linear equation. First, we are given matrix A and vector B. From this, we write the system of linear equation from the augmented matrix A, B. Next, we convert the augmented matrix into a suitable from B range the equation so that each equation is solved for one variable. This step is important to ensure the Jacobi method converges properly. After that, we derive the Jacobi iteration formulas where each variable x1, x2, and x3 is expressed in terms of another variable from the previous iteration. For the second condition, we start with the interval gives x0 minus 2 0 0 0. Using the iteration formulas can be computed successives approximation x1 and x2 and so on. Be substitute values from the previous step. We continue simpling the agreement metric by eliminate the element below the row to pivot. Using elementary row operation, we apply the operation R3 equal to 73 per 3 6 R2 to eliminate the value under the pivot in the second row. After performing this operation, we obtain a new agremented metric where the system is now closer to row echelon form. From this metric, we can write the corresponding system of equation. The first equation remains 4x1 plus 7x2 minus 6x3 equal to negative 4. The second equation simplifies to negative 9x2 plus 7x3 equal to 8. And the three equation now involves only x3. This simplified system allows you to easily reach each equation, which is necessary to set up the Jacobi iteration schemes in the next step.
Now we have to rearrange our EF equation for Jacobi. From the first row, we got 1 over 4 in the bracket negative 4 minus 7x2 plus 6x3. From second row, we got 1 over negative 9 in the bracket 8 minus 7 x3. From third row, we got 36 over 97 times by 65 over 9. For iteration 1, after we compute all those three equations, we will get negative 1, negative 8 over 9, 260 over 97. Same goes to iteration 2. After we compute all those together, we will get 90 over 97, 116 over 97, and 260 over 97. So the analytical solution is 90 over 97, 116 over 97, and 260 over 97. The REF-based Jacobi method converges rapidly to the exact solution. This confirms the theoretical condition that Jacobi converges when the spectral radius of the iteration matrix is less than 1.
Hi, I'm Nur Shafina binti Sherry and I'll be presenting part 3B of this project. For part 3B, I implemented the Jacobi method using Python with the aim of verifying the accuracy of the manual Jacobi iteration from part 3A and the analytical solution obtained in part 2A. In this part, the metric A and vector B were defined using the row echelon form system, and the Jacobi iteration formula was applied to update each variable based on values from previous iteration. The stopping condition was set to 2 iterations because from the manual calculation, the solution was observed to converge exactly after the second iteration with no further change in the values of x1 and x2 and x3. After executing the Python code, the Jacobi method produced the solution x equal to 90 per 77, 116 per 77 per 97, and 260 per 97, which is identical to the result obtained from the manual Jacobi method and the analytical solution. This consistent agreement between the Python output, the manual iteration, and the analytical solution confirmed that the Jacobi method was implemented correctly in the Python. Overall, this result demonstrates that applying the Jacobi method to the row echelon form
System provide fast, stable and reliable conveyance for solving this system of linear equation. Thank you.
That's all from us. Thank you.